Have you ever wondered how does the Master Sword work? How durable is the Master Sword? I have been researching the art of sword making for the past month, and I found out that sword making isn't just about hitting hot metal with a hammer. Yes, after I made the Hylian Shield video, which I'll put a link in the description, somebody asked me, what about the Master Sword? So I looked into it. Let's see how the Master Sword would be made. I thought that we should look at what goes into making a sword. After all, we need to know what goes into it so we know what to keep in mind as we add light and energy wave things. It turns out that making a sword is very complicated. Didn't see that coming, did you? When making a sword, there are four main factors to think about: hardness, strength, flexibility, and balance. Hardness is important because the blade needs to be able to hold a stable edge. As I mentioned in the Hylian Shield video, the cutting edge is much smaller than the visible edge. The blade needs to be strong enough to absorb shock waves of a blow. After all, every action, like a swing, has an equal reaction. Flexibility is important because the sword needs to be able to move easily through air or a material. And finally, balance, which is making sure it's light enough to use but heavy enough to do damage. Let's go over the parts of a sword as well. There's the edge, which is the cutting part. The tip, that's the part farthest from the hilt, which narrows into a point. The flat is the top and bottom. The fuller is a groove that runs through the sword. People used to call this a blood gutter because they thought that was where the blood would run through, but in fact it's used to help balance the blade. The bladesmith would be able to remove the material and weight and yet keeping it strong. The ricasso is a blunt section before the blade reaches the guard. This wasn't on all swords, but we find it here. Tang is the part of the blade that is covered and held. It is the part here. The guard is the part that blocks your hands from enemy attacks. The hilt is the actual part you hold. That covers the tang, and the pommel is the bottommost part, providing a counterweight and stopping your hand from slipping. Okay, so how are swords made? I know you're anxious to get to the hammering and all that. We need to decide on a couple of things. The process first starts out by choosing a design. That way the smith can decide what attributes the metal needs to have. Some swords, like rapiers, are very flexible, while others, like broadswords, focus more on hardness. Now, we already have a design. The Master Sword is very obviously a broadsword. Next, a method is chosen. There are a couple of methods that determine the metal. Forging is where you heat the metal and pound into shape. Now, stainless steel doesn't forge so well, so a smith would use stock removal, a process of grinding down stock bars of stainless steel. The most common form of sword making is forging, so that's probably what happened. Finally, we decide a metal. A variety of metals have been used throughout history. The first bladesmiths used copper, but it was too flexible, so they switched to bronze, a stronger metal. The other things they did is vary the amount of tin to make certain parts harder. Finally, we get to steel, popularized by Romans and then by the Japanese. Obviously, this game was produced in Japan and it is a Western style of sword, so it is safe to say that the Master Sword is made of steel. Now we can finally get to the forging. Most smiths use electric or gas forges, but they used to use coal forges, which is most likely what they used in the creation of the Master Sword. The goal of a forge is to get the metal red hot and glowing orange. This is about 1,800 degrees Fahrenheit. To put this in context, it's about the heat of lava. This is because if it is too cold, the steel will shatter. The next step is to do what is called drawing out, which is when you lengthen the metal by reducing the thickness, so basically using a rolling pin. This flattens it into a sword shape. You can also create a curved blade by hammering along one edge. Afterwards, the smith will taper the blade. This creates the tip and the tang. This is created by hammering at a specific angle, but doing this creates bulges, so the smith will draw out that part a bit. They continue this process until they have the desired point. Now that the tang is finished, the smith will create a thread on the end like they use on screws. This allows you to screw on the pommel. Now the smith doesn't heat the entire blade at once, because that would be inefficient. By the time they are done with one section, it is already cooled. Instead, they will heat the blade in 6 to 8 inch segments. Every once in a while, the smith will heat up a blade to a certain temperature. This temperature creates austenization, which means the iron and carbon molecules start to mix. Then the smith lets it cool without altering it. This is called normalizing and is used to smooth the grain out. After making sure the blade is evenly worked, it is annealed. This process will heat the metal to the same temperature where it austenizes, but the difference is that the metal is cooled very slowly, taking hours or even days. This softens the metal so that it can be easily cut or grinded. Now, bear with me. I know this is getting long. Now, the smith can engrave any design they choose. The blade will now be too soft and will not hold an edge if we cut one. Remember, the blade needs to be hard. So, we heat it back up to that same temperature, then is immediately placed in the quench tank. This tank is designed to make sure the blade is cooled quickly and, more importantly, evenly. Now it is tempered. This process involves, wait for it, heating up the metal again. This time you don't heat it to the austenization point. Instead, it's a lot cooler. It stays in that heated state for a while and then gets quenched again. This can happen many times to get the right hardness. One method that the Japanese use is covering sections in clay so the blade would cool slower in certain areas, making it more flexible at points. Finally, we grind out the edge. We are almost done. The smith welds the guard in place, then adds the hilt. Our hilt will be made of leather. Finally, they screw on the pommel. Now, they will normally polish up the blade, and then we get a whetstone and sharpen the blade. So, that was a lot to go through. It was over 2 pages long. But we still don't have the master sword. We have a regular sword. What a lame-o we are. The good news is that now we understand what goes into a sword. We can add accessories like lights and this wave thing. Now, that wave thing, that's plasma, not lasers or lights. Just as lightsabers and blasters don't use lasers or lights. Plasma is the fourth state of matter. Out of, well, it's debatable. There are at least 5 states of matter: solid, liquid, gas, plasma, Bose-Einstein condensate. NASA has added fermionic condensates, and others have added more. Plasma is superheated gas. You guys know this. Now, how would you send this at an enemy? Well, I try to relate this to things people ask about. When you think of shooting people with plasma, what do you think of? That's right, Star Wars. So, how do blasters work? According to Wikipedia, blasters superheat gas, converting it to plasma, and then firing it in an intense beam. We need to contain gases in the sword, create a heating mechanism, and a firing mechanism. The wave is created because Link swings the Master Sword. At the very least, gases needs to be 6,000 Kelvin. For those who don't know or forgot, 1 Kelvin is negative 272.15 Celsius? Wait, when you add negative 1 to negative 1, you get negative 2. So, 2 Kelvin should be negative 544.3 degrees Celsius, but instead it's negative 271.15 degrees Celsius. And we put in our 6,000 Kelvin, we get 5,726.28 degrees Celsius. Yeah, Kelvin makes no sense. For those who don't know, 1 degree Celsius is 33.8 degrees Fahrenheit, and 5,726.28 degrees Celsius is 10,339.304 degrees Fahrenheit. It's all messed up. Now, how do we heat something that much? That part is hard. Our forge that made our sword only goes up to 3,500 degrees Fahrenheit, and that's almost 7,000 degrees colder than we need, and those are huge. But the biggest problem is making sure it's not too heavy, which it certainly would be, and making it balanced. So sadly, we must accept the truth that the Master Sword is a thing of legend, and we shall never obtain it. Subscribe, leave a like, share with family and friends. Tell me in the comments if you think there's another way to do this, or if you like this better or worse than the Hylian Shield. See you next time.